So this is the solution for question 3 of homework 1. In the question, we are given a binary channel where the probability of sending 0 is 0.6 and the probability of sending 1 is 0.4. In the question, we were asked to find the probability of receiving 0 at the receiver and the probability of error. Let us denote the event E to be receiving 0 at the receiver. So the event E can happen in two ways. One is if 0 is transmitted by the transmitter and 0 is received by the receiver, so there is no error. And the second case, if 1 is transmitted by the transmitter and due to an error 0 is received at the receiver. So using the total probability theorem, the probability of E is P of, or the probability of receiving 0 given that 0 has been transmitted multiplied by the probability of 0 being transmitted plus the probability of receiving 0 given 1 has been transmitted multiplied by the probability of 1 being transmitted. The values of P of 0 given 0 are 0.7 and the probability of 0 is 0.6. Probability of 0 given 1 is 0.2 and probability of 1 being transmitted is 0.4. Plugging in the values, we'll get P of E equal to 0.5. So similarly, the probability of 1 being received will also be 0.5 because the sum of these two probabilities must be equal to 1. Moving on, the probability of error in the system. So an error in the system can happen in two ways. The transmitter, let's say the transmitter transmits 1 but the receiver receives 0, or if the transmitter sends 0 but the receiver receives symbol 1. So similarly, like the above case, using total probability theorem, probability of error is probability of 0 being received given that 1 has been transmitted multiplied by the probability of 1 being transmitted plus probability of 1 being received given 0 has been transmitted multiplied by the probability of 0 being transmitted. So probability of 0 given 1 will be 0.3, it's in the question, and probability of 1 given 0 is 0.2. So plugging in the values, we get the probability of error to be 0.26.